Here's example 3 with finding vertical asymptotes for trig functions in general. So this one's a secant. So in example 1 we did a tangent, example 2 was a cotangent, now we're going to do a secant. And actually it's going to be pretty much identical to example 1 where we did a tangent, because tangent and secant, their denominators are both cosine. So really, if we change the secant to tangent, absolutely nothing would change in this problem, which is pretty nice. But anyway, so example 3, find the general equation for the vertical asymptotes of f of x equals -3 times the secant of the quantity pi over 2x plus pi over 4, and then minus 1. Find 3 specific equations of vertical asymptotes. Okay, so we're going to approach this just like we did with examples 1 and 2. So first thing we do is write original, as in the original equation of the vertical asymptotes. And again, for secant and tangent, it's literally exactly the same. So what we're going to do is say x equals k pi plus pi over 2, where k is any integer. Okay. So k represents any integer. Okay, so why k pi plus pi over 2? Well, remember, in general, and we talked about it in a few videos, it's 2k plus 1 times pi over 2. But if you distribute the pi over 2, then you'll get 2k times pi over 2 plus 1 times pi over 2. Okay? And then these 2's cancel, and you end up with k pi plus pi over 2. Okay, so that's why we have that's why we have k pi plus pi over 2 here. Okay, so anyway, we really could use the other form, but it's in general it's better to use this form for tangents and secants because it'll simplify a little nicer. So anyway, that's the original equation, original general equation for the vertical asymptotes, because for y equals secant of x. Okay, so for secants and for tangents, you take the entire expression inside of the trig function and set it equal to k pi plus pi over 2. Okay, so now for our new one, okay, what we want to do now is find the new general equation for our new trig function we were given here. So the new one is going to be take the entire expression inside of the trig function, pi over 2x plus pi over 4. So we take pi over 2x plus pi over 4, and we set it equal to k pi plus pi over 2. Okay, so take that entire expression inside of the trig function and set it equal to k pi plus pi over 2. Okay, so just like we did here, we took the entire expression inside of the trig function, set it equal to k pi plus pi over 2. Do the exact same thing here. Take the entire expression inside of the trig function and set it equal to k pi plus pi over 2. Okay. So again, the only thing that matters is that we have a secant and we have to pay attention to what's inside of the trig function. This -3 changes absolutely nothing. This minus 1 out here changes absolutely nothing. The fact that we're calling it f of x instead of just y changes absolutely nothing. Okay? So all that matters again is that it's a secant and not a cotangent or cosecant. So actually, if this were a tangent, absolutely nothing would change. It would be exactly the same thing. Because again, tangent and secant have the exact same vertical asymptotes. Okay? But anyway, so we have to pay attention to the trig function and what's inside of it. So take the entire expression inside of the secant, set it equal to k pi plus pi over 2. Okay, so once we've done that, the next thing we do is we solve for x. Okay, so solve for x, you're going to have an answer in terms of k. So let's zoom in and work on that now. Okay, so first we want to rewrite this equation without the red box on it, I guess. So that's going to be pi over 2x. So let's set aside some space here. Okay. So maybe not separate that because that's still really part of that new part there. Okay, so this is going to be, let's write it down here, pi over 2x plus pi over 4 equals k pi plus pi over 2. Okay, so let's come up here now, and we're going to subtract pi over 4 from both sides. We want to solve for x, so first subtract pi over 4. So we're going to have pi over 2 times x equals k pi plus this pi over 2 is still here, and then we're subtracting pi over 4. Okay, so we have to get a common denominator here, so that's going to be pi over 2x equals k pi plus, so pi over 2, if you multiply this by 2 over 2, so multiply by 2 on top and a 2 on bottom. Okay, so that's going to be 2 pi over 4 minus 1 pi over 4, right? So then we end up with pi over 2x equals k pi plus, so 2 pi over 4 minus 1 pi over 4 is just plain old 1 pi over 4. Okay. So now we multiply both sides by 2 over pi. So let's take this. Okay, so let's do this. We're going to multiply this side by 2 over pi. And then we're going to multiply this entire side by 2 over pi. Okay. So really it's pi over 2 times x equals this mess, so we really want to divide everything by pi over 2. But if you divide by pi over 2, you're multiplying by 2 over pi. Okay, so again, the 2's over here cancel, the pi's cancel, so we're just left with x, that's good. So then what we do here is distribute. So this is x equals k pi times distribute, now we have 2 over pi. And then plus pi over 4 times 2 over pi. Okay. So pi's cancel, that's good. Pi's cancel over here too, that's great. 2 over 4 simplifies to 1 on top, 2 on bottom. Okay. So then x equals k times 2, so we'll say 2k, and then plus 1/2. Okay. That's fine, that's a totally acceptable answer, but again, just like in example 2, let's go ahead and get a common denominator here. So we don't have any pi's in this answer, which is nice, actually. Okay, so we'll get a common denominator here, just so we can make the next part simpler. Okay, do we have to do that? No, we absolutely don't have to, but it will save us a little bit of trouble later on, so why not? Okay, so if we want to get a common denominator, so this is really 2k over 1 plus 1 over 2, so the least common denominator would be 2, so multiply this guy by 2 over 2. So that's going to be 4k over 2 plus 1 over 2. Okay, so really it's going to be x equals 4k plus 1 all over 2, where k is any integer. Okay, so again, it's sort of implied that k is any integer when you have that, but it's good to be thorough, so we'll write it at the end. But we don't want to write it on every step because we want to save the room. We don't really have to write it on every step because it's not really consequential there, but anyway, we just want to keep it here, just to be thorough. So this is the answer to the first part. So find the general equation for the vertical asymptotes for that function we were given. Okay, find the general equation for the vertical asymptotes for this guy here, and that's what we just did. Okay? Using the exact same process that we did in example 1 and example 2. Okay, take the entire expression inside of the trig function, set it equal to some other expression depending on what function that is. So since it's secant, then we have to use k pi plus pi over 2. Okay, we took the entire expression inside of the secant, set it equal to that, solved for x, went through some algebra, did some stuff, some things here, and simplified, got a common denominator, and we have that. Okay. Now we find 3 specific equations of vertical asymptotes. Okay. How do we find 3 specific equations? The same way we always do, same way we've always done in the last 2 videos, in examples 1 and 2. So we just pick 3 specific values of k. Okay, that's it. So let's go ahead and choose. Well, let's set up our chart. Okay, so we'll erase this stuff here, set up some room, make some room, set up our chart. So we're going to have, let's zoom out a little bit maybe. Okay, so we've been using k equals -1, 0, and 1. We used -2, -1, 0, 1, and 2 in the first example. So let's use some different values. Not terribly different values, but we'll say k over here, and then VA for vertical asymptote here. Okay, so -1, 0, and 1 are great examples to use, but we don't have to use those. K really, it says find 3 specific equations of vertical asymptotes. We can pick any 3 values of k we want. Okay, so here's our general equation right here. X equals 4k plus 1 all over 2. Notice there's no pi in here, and sometimes that'll happen, right? So that doesn't mean we did anything wrong, it just means it worked out kind of nicely. Okay, so I mean, do be careful, it won't always happen like that, but if you do it right, then you won't really have to worry, of course. But anyway, so we don't have any pi's here, that's nice, so it'll simplify it a little bit once we get specific equations. But anyway, so what we do is just pick 3 specific values of k, plug them in here one at a time to get 3 specific equations of vertical asymptotes. Okay? So instead of -1, 0, and 1, let's maybe use 0, 1, and 2. So I know not terribly different, but just want to emphasize the point that we don't always have to use -1, 0, 1, and things like that. So let's use 0, 1, and 2. Let's, you know what, just for the fun of it, let's, instead of 2, because we used 2 in example 1, let's maybe use 0, 1, and 10. Okay. Why? Just because we can, and nobody is going to stop us. So, okay. What happens when k is 0? When k is 0, what do we have? We have x equals 4 times 0 plus 1 all over 2. Okay? 4 times 0 is 0, 0 plus 1 is 1, so that's 1 over 2. So this is going to be x equals 1/2. Okay? So again, we mentioned it in examples 1 and 2, and we'll mention it again in example 4, but you do want to be careful. When you do vertical asymptotes, it is a line, so your answer needs to be an equation of a line. So it's not enough to just say 1/2, okay, because your answer has to be an equation of a line, because a vertical asymptote is a vertical line, so your answer must be the equation of a vertical line. So that's why we have to say x equals 1/2. Okay, it has to be x equals some number. Once you find the specific equations, okay, x equals a number. Just like over here, for the general equation, it has to be x equals da-da-da, okay, in terms of k, for the general equation there. Okay, what happens when k is 1? Then we have x equals 4 times 1 plus 1 all over 2. Okay, 4 times 1 is 4, 4 plus 1 is 5, so that's 5 over 2. So x equals 5/2, okay? Okay, and the last one, when k is 10, then we have x equals 4k plus 1, so that's going to be 4 times 10 plus 1 all over 2. 4 times 10 is 40. 40 plus 1 is 41. 41 over 2 cannot be simplified because 41 is not even, so this is just x equals 41 over 2. Okay? So why did we use 10? Again, because we can, why not? I just want to emphasize the point that we don't always have to use numbers that are close to 0 or numbers that make that simple as possible. It's best to use those, so 10 might not be the best choice. But notice this wasn't that terrible, right? It actually wasn't that bad at all. So if we use 2 instead, we just have 4 times 2 plus 1, which isn't really any simpler or harder. But anyway, the point is 3 specific equations of vertical asymptotes. If you want to find those, just pick any 3 specific values of k and plug them into here one at a time. Okay, that's all we have to do. Okay, so it might seem like a lot, but really I'm just talking a lot. And when you explain it, again, when you explain things, it just makes it seem a lot longer than it really is. But this entire process really is not that long. We just set up the original, or write down what the original is, write down what the new is, solve for the new thing for x. That usually is the most difficult or messy part because you might have some messy algebra. Anyway, solve that for x, you'll get something in terms of k, like over here, and then pick 3 specific values of k to get your answer for the specific equations. Okay, so anyway, that's example 3 with finding vertical asymptotes for trig functions in general.